We now talk about alternating current generator. So consider a coil A. So say this is a coil A, and this coil A lies in a magnetic field. So you have a north pole and you have a south pole. And this coil A, this is a wire loop coil and it has N turns. So this is rotating in the magnetic field. So we have a magnetic field and it is rotating in the magnetic field with some constant angular velocity omega. So it is rotating with this constant angular velocity omega. So the magnetic flux through the coil at any point in time, so this flux is given as this integral of magnetic field dot product with the small area vector, and this becomes BA cos theta. You already know that this will decompose as B dA cos theta, and then you integrate over the area A and you get BA cos theta. Now since the angular velocity is omega, this theta is equal to omega t. So the magnetic flux through the coil at any time t, this is given as BA cos of omega t. So we replace theta with omega t. Now we know that this EMF is given as minus n d by dt of d phi. So you can write this as minus n d by dt of BA cos of omega t. Now n is constant at anyways outside, BA are also constant, so you take them outside. And you know that d by dt of cos of omega t is minus omega sine of omega t. So minus sign cancel out and you end up with NAB omega sine omega t. So you notice the sine symbol here. So we see that this EMF or electromotive force, this varies sinusoidally with the time. So you have the sine here, so that's why we are saying it varies sinusoidally with time, and the maximum value occurs at theta equals to pi by 2. So this is how the electromotive force varies with time. So this is the electromotive force in this direction and this is time. So the maximum value occurs here at pi by 2, and this you denote by this E subscript m, and the value of E subscript m is NAB omega. Now we come to an example. So the example says that suppose there is an AC generator, and this AC generator consists of a coil with 10 turns. The area of the coil is 0.01 meter square and the resistance is 10 ohms. So this coil is rotating in a magnetic field of 0.5 Tesla and the frequency is 50 Hertz. So omega is equal to 2 pi f. So this you should know, the formula of how to obtain angular velocity from frequency in Hertz. So then the maximum EMF, so we are going to use this formula right here. So EM is equal to NAB omega. Just plug in the values, you get 15.7 volts. So the maximum current flowing through the generator coil is given as, so we are again using the modified formula of V equals to IR. So we just plug in the values. So we are given resistance as 10 ohms right here. So you plug in 10 ohms here, 15.7 volts you take from here and plug in here. You get the value of 1.57 amperes.